Okay, let's go.
Okay, let me share my screen here, hopefully. Let's see here, share. And let me put it in presentation mode.
Yeah.
It usually takes twice. Oh, there it is. How about that? Ta-da. It should show up.
It should.
Oh, right. Well, if you haven't figured out by now, I'm Carl, K9LA. We're in Fort Wayne, Indiana. My wife is, whoops, how did that advance? I didn't do it. My wife is Vicky,
Okay.
Alpha
There we
Echo
go.
9 Lima, AE9YL. That really helps too, she being a ham. And I'm going to talk about solar topics and propagation. And this is an update from a year ago when I presented to your group. So you may see some stuff again, but there's enough new stuff, specifically talking about cycle 25. So let's get started. Like I said, it's been a year, so I'm a year older. It's kind of arguable if I'm a year wiser. I don't know, whatever. And the big thing is Vicki and I didn't go anywhere in 2020. Everything got canceled. The biggest one is we were really disappointed not going to the Cayman Islands ZF for the ARRL 10 meter contest. We've been doing that quite regularly. And of course, there was some decent sporadic E last December, and we weren't there to take advantage of it. So that's the way it is. But the good news is we sure saved a lot of money by not going anywhere. Just think, you know, all that money is going to be available when I'm a silent key, right? Right. Mm-hmm. Okay, we can talk about a very quick update on cycle 24. Not much to say. Talk about the current solar minimum, what to expect on the bands. It sounds like you guys are pretty active, so I'll hustle through that. You probably know all that. Talk about the cycle 25 predictions and how cycle 25 is doing. And let me say that thank you for everyone showing up. A lot of the calls I recognize from contests, so that's good. Let's keep contesting. Okay, cycle 24 update. Not much to say. There's cycle 24 in terms of the 10.7 centimeter solar flux. The black data is the monthly mean. You can see it's kind of spiky, and that's why we further average it to get a smooth data. That's the blue line. The last sunspot we saw from cycle 24 was in July 2020. And probably we're not going to see any more cycle 24 sunspots. Cycle 25 has started up. You can see by the smoothed line, the blue line there, it's hit the bottom in December 2019, and it's starting to go up. So that's about all I can say at the moment. Current solar minimum. Here's a picture of previous solar minimums. There are 5 on the left. That's from the minimum between cycles 18 through 19 through cycles 22 and 23. We went below a smooth sunspot number of 20 and ascended up through a smooth sunspot number of 20 in about 2 years. So we had some pretty short solar minimum periods, which is great. Get them out of the way and then go to the higher bands where the signals are a heck of a lot stronger. And then the minimum between cycles 23 and 24, the last minimum, extended out to almost 5 years. That's the heavy green line. Well, that looks like it carried through here to the current minimum. That's the red line between cycles 24 and 25. Like I said, the min was in December 2019. And it looks like the minimum is going to be just as long as the last minimum. Now, the next slide will show the correlation between the duration of solar minimum, in other words, how many months we spent below a smooth sunspot number of 20, and the amplitude of the next cycle. And what you can see is there's a decent correlation. The correlation coefficient is 0.764, which isn't too bad. And what it tells, well, it doesn't tell us, what it suggests is the longer we spend at solar minimum, the smaller the next cycle is going to be. Now remember this plot, because it's going to be in contradiction to one of the big cycle 25 predictions, and it'll be interesting to see which one comes true. So the longer the duration, the smaller the next cycle. Okay, what to expect on the bands? Very quickly, 20 meters should be open worldwide during the day and early evening. And that's because even though we have 0 sunspots and solar 10.7 centimeter solar flux around 65 to 70, there's still enough extreme ultraviolet coming from the sun to produce enough ionization for 14 megahertz to refract back to Earth. So 20 meters, of course, that also means the lower bands are going to be open too, because there's enough ionization to refract them back to Earth. The low band should be open worldwide at night. Of course, you should always pay special attention to sunrise and sunset. I get the feeling that many believe 160 isn't as good as it should be. I don't think it's as good as our last solar minimum, and especially not as good as the solar min in the 96, 97 timeframe, 1996, 1997. There may be a physical reason for that, and it's tied to galactic cosmic rays, but that's a story for another day. You should always look for occasional openings on the higher HF bands, mostly of a north-south nature and a VKZL. And of course, don't ever forget about sporadic ether in the summer and December. And yeah, it's great to have multiple antennas on 6 meters for ES, because there can be openings in many directions at once, and it's tough to wear out your rotator. Always take advantage of the digital modes. They've really got a lot of people active on the higher bands when normally CW and sideband just wouldn't make it. And always watch for short-term enhancements on the higher bands when the K-index spikes up a bit. I probably showed the 2018 California QSO party where there was a small spike in the K-index, and that caused 10 meters to open up on Sunday between the Midwest and California. So, short-term events happen. We have trouble predicting them because we just don't understand the short-term events that happen in the ionosphere very well. Okay, now let's get to the meat of this program. Cycle 25 predictions. Let's kind of review cycle 24 predictions. There was about 57 of them. The predictions range from a smooth sunspot number of 40 to a smooth sunspot number of 185. Now, with that many predictions, someone was bound to be right. And now, why are there so many predictions? Because we just don't fully understand the sunspot process. We're learning every solar cycle a little bit more, but unfortunately, solar cycles take 11 years, so the learning is quite slow. It takes a while. Because there were so many predictions, the Solar Cycle 24 Prediction Panel, which is which came out of NOAA and NASA, they initially issued 2 predictions, and that's what the yellow and the dark green, the red and the dark green is their way on the right. That's cycle 24, and they predicted a low cycle and a very high cycle. Now, as the solar minimum lengthened between 23 and 24, the consensus was for a low cycle. Remember that graph I showed where the duration at solar min, the longer you spend at solar min, the smaller the next cycle is going to be. So that's kind of what eventually drove the prediction for cycle 24 down to the lower prediction. And here's what cycle 24 actually did. The prediction was for 90. It hit a maximum of 81. So it came kind of close. And that also says some of those predictions were correct, but I don't think they were correct for the right reason. Yeah, oh well, let's leave it at that. Okay, one thing we should talk about is we do have new sunspot numbers. It's important because we can get confused. And it all starts with Rudolf Wolf back in 1849. He devised the sunspot number, and it involves the number of sunspot groups and also the number of individual sunspots. And it also includes a K factor, which I guess we could call a fudge factor now. The K factor includes, your telescope. Is it a better telescope, a worse telescope? Viewing conditions, and also observer bias. Now, what happened was the successor to Rudolf Wolf was Alfred Wolfer, and he applied a K of 0.6 to make his counts agree with Wolf. In other words, Wolfer counted more sunspots than Wolf did. Well, that's not good, but it happened. And that factor of 0.6 has been applied forever. Now, there's some concern about the old sunspot numbers. Began in the early 90s, and beginning in 2011, there were 4 workshops, sunspot workshops held, and they reviewed all the old data, and the result was a new sunspot data set, and it's called the V2, version 2, whereas the old is a V1. It removed the 0.6 factor, and it corrected some other less major issues. And ever since July 1st, 2015, the Royal Observatory of Belgium, they're the official sunspot reporters, began reporting the new sunspot numbers. So when predictions came out for cycle 25 that were kind of early in the time frame, there were some that were version 1 and some version 2. So you just got to be aware of that and figure it out. Now here's just a plot of the version 1 sunspot record versus the version 2 sunspot record from 1950 onward. And you can basically see when the 0.6 factor was removed, that the new sunspot numbers were a lot bigger. That's just the way it is. Now, unfortunately, our propagation predictions have a model of the F2 region that's based on the old sunspot data. So what that means is our propagation predictions are going to be off if you input the new sunspot data. And the difference is about 1 band, optimistic. So the V2 data will maybe say that 17 meters or 15 meters is open, when the V1 data would only have said that 14 megahertz or 20 meters is only open. Of course, you can see the biggest difference in the V1s and V2s is that solar maximum. When you're at solar min, it doesn't really matter that much, because near zero is near zero for whichever data set you use. And one of my anchor points in the old data was always cycle 19. It hit a maximum smooth sunspot number of 201. Well, that's not anymore. So now I have to memorize that cycle 19 really hit a smooth sunspot number of 285 or so. So, oh well, I think there's enough room in my brain to remember that, so that's good. Fortunately, I haven't lost too many, still a lot of good neurons are firing up there. So here's cycle 25 predictions. This came from January of last year, from a sun climate presentation in Tucson. There were 38 predictions, and I was aware of 2 more predictions for a total of 40. And you can see they go from 50 all the way up to, let's see, 250, about 230 something. So we haven't learned that much about the sun. We still have predictions over a very wide range. Now here's a distribution of those 40 cycle 25 predictions. And I split them up into buckets of sunspot numbers. For example, 10 predictions had a prediction of a maximum smooth sunspot number between 100 and 124. And you can see that there's quite a few kind of in the lower buckets. The red average cycle arrow points to what the average solar cycle is over all 24 solar cycles. So you can see that 34 of the 40, 85% are for a below average cycle. Wow. 3 are for an average cycle. Those are the ones in the 175 to 199 bucket. And 3 out there on the right are for a big cycle. And one is from Dr. Scott McIntosh and et al. And others. And we're going to talk about that one in a little bit. Now, since then, I found even more cycle 25 predictions. Now there's 53 of them. And what that chart shows is the different methods of making a prediction. So, you know, they're all over the map. And the distribution really hasn't changed that much because 50 of the 53 are at or below an average cycle. So a very high percentage are for an average or below cycle. There are 3 in there that say it's going to be a bigger cycle. So let's look at the lowest prediction. That came from a gentleman named Javariah in 2017. And the fundamental basis for his prediction comes from a Gleisberg cycle. So what does Gleisberg mean? Well, the 11-year solar cycle was discovered, I guess you'd say, by Schwab. And so people call it a Schwab cycle at times. Now, really, the solar cycle is really 22 years, and that's because the sun changes its magnetic orientation at the maximum of each sunspot cycle. So a full cycle is really 22 years to get back to the same magnetic orientation. Then if you look at all 24 solar cycles, you'll see that we've had 3 periods of high sunspot cycles and 2 periods of low sunspot cycles. And the period is approximately 80 to 100 years for that. And that's where the Gleisberg, I guess he's the guy that discovered it. Now there's some even longer periods. Zeus de Vries, 200 years, Hallstatt, 2,400 years. And we can kind of determine that from proxies for sunspot numbers. For example, carbon-14 and tree rings, and also beryllium-10 and ice core samples. So we can kind of get an idea of what the sun was doing a long time ago. And that's where these other periods come from, these longer periods. So what Javariah did is he took all 24 cycles, and that's what those 24 red dots are. He fit a linear trend line to all of those and subtracted that trend line from the sunspot data. And what it gave is the chart that's shown there in the lower left. It gives data centered about 0. Okay, so what did he do next? He fit a cosine function to that data. And that's what that looked like. Unfortunately, that fit is not very good. I mean, it's pretty obvious that the red dots aren't falling onto the blue cosine line. So he looked at 2 other factors, the Ganeveshev-Ohl rule, which kind of says that there's a relationship between odd number and even numbered cycles, but it doesn't hold true for every pair over the 24 cycles. He also looked at orbital angular momentum of the sun about the center mass of the solar system. I don't claim to understand all that, but what it came down to is his prediction of 35 plus or minus 5, which is the old sunspot number, and that translates to a new sunspot number of 50 plus or minus 7. So that's a pretty low cycle. Probably not going to happen, I hope. Now here's the NOAA-NASA solar cycle 25 panel. This is their prediction in red. They predict a maximum of 115 in mid-2025. That's about the same as cycle 24. That's what their prediction is, and you can see that at the URL there at the bottom. Now what I've done is added 15-meter pointer, 10-meter pointer, and 6-meter pointer as when we should expect 15 meters to be consistently open worldwide, and when 10 meters is supposed to be, or should be consistently open worldwide, and 6 meters also. Um, let's see, what I was going to say something, I forgot. Of course, okay, yeah, this depends on the solar cycle not being very much greater than the past solar cycle 24. Now, if we get a real big cycle, those dates will be earlier because a big cycle rises faster than a smaller cycle. And we'll look at that towards the end. Okay, here's the high prediction from McIntosh and others. And the basis for that production is the inferred magnetic activity bands. Now, what you're looking at, all those black dots are where sunspots emerged on the solar disk. And when a new cycle starts, the sunspots occur at the higher solar latitudes. And as the sunspot cycle progresses, the sunspots emerge closer and closer to the solar equator. And that's called a butterfly diagram because it the black dots kind of look like a butterfly, I guess, the wings or whatever. Now, what McIntosh and others did was put on those red and blue areas that are the inferred magnetic activity bands, and they extrapolated them to where they hit zero. Now, and what they called the point where, like for example, solar cycle 23, the magnetic bands met at zero, they called that the termination date. And there's a termination date for cycle 22 here and a termination date for cycle 24. And they went back and looked at all the 24 solar cycles and came up with the termination dates. So, and that's in the tabular data. Now, I'm a little puzzled, but because the data here in the tabular figure doesn't necessarily agree with where the lines meet at zero. And that's what those X's are. That's the green X's are ones from the tabular data, and they don't really line up with the with that endpoints. So I kind of wonder what's going on there. And the red X is their estimation for when the cycle 24 termination date is, which is 2020.37, which is April 2020. So yeah, I don't know what that means, but we'll have to wait and see, I guess. Oops, hit the wrong thing. We'll get back to that in a little bit here. So cycle 25 sunspots. We saw some cycle 25 sunspots in December 2016, November 2018, et cetera, just like what's shown in the chart there. But they were all small and of a short duration, so they weren't assigned an active region number. So they didn't count, although they were there. Now, July 8th, 2019, that's when we saw the first longer duration cycle 25, and it was assigned an AR number, active region number, 2744. And that's the first official cycle 25 sunspot. And that's circled in yellow there. Remember I mentioned that sunspots emerge for a new cycle at the higher solar latitudes, and you can see that's what happened down here. If they would have emerged at around the solar equator, that would have been a cycle 24 sunspot. So cycle 25 is alive, and I think everyone's aware of that. So how is cycle 25 doing? Well, it's not doing too bad so far. There's the raw data. What I did is looked at cycle 19 in blue, cycle 24 in red, and cycle 23 in green, and I lined up solar minimum to be at the 0 point. Because what I wanted to do is look at how fast the solar cycles are rising. So that's what the thing on the left, the chart on the left shows a straight line from when solar minimum was for each solar cycle to the data at the 6-month point, because that's all we have so far for cycle 25. We have 6 months of data past solar minimum. Now what you can see is cycle 24 in red rose quite slowly until the 6-month period, whereas cycle 25 kind of paralleled cycle 19 in its rise for the first 6 months. Early data, we'll have to wait and see what really happens. And what I missed in saying here is on the previous chart here. Oh, I think I skipped that one for some reason. I don't remember seeing it. Here's the tabular data again. And what they did was plotted the time in years between termination dates and the maximum of the next cycle. And that's what they came up with. And they're saying that McIntosh is saying that the time in years between the termination date of cycle 23 and cycle 24 is about 9.3 years. And if you enter 9.3 on this chart, it says it's a very big cycle. So obviously that contradicts with the chart on slide 8, which said a long minimum is a small next cycle. So I'm not sure which one's going to come out true, but we'll probably find out hopefully within the next year by seeing how fast cycle 25 is rising. So not sure what to say right. So that's all I had. The summary, the solar min occurred in December 2019. That's when the maximum, that's when the smooth sunspot number minimized for the solar min period between 24 and 25. Most believe cycle 25 is going to be small. A few predict a big cycle 25. Always remember that the low bands in 20 and 17 will still offer worldwide DX QSOs. And don't forget east of S, sporadic E. Beware of extremely short events on the higher bands and on 160. The short-term events on the higher bands, that's kind of like the California QSO party of 2018. On 160, I've seen lots of reports of a small spike in K index improving 160 meter propagation across the higher latitudes. So something's going on there. So, you know, always just keep an eye on it. And of course, the digital modes will make this solar min the most active in history on the higher bands. And take advantage of FT8 and FT4 if that's one of the modes you like to use. So that's all I had, Roger. Any questions, I'd be glad to answer. Hopefully I can answer.
Hey, thanks a lot, Carl. I did have a question. This McIntosh put out his sort of new methodology, what, a couple of years ago?
Yeah, but I think it was 2017 or maybe even before that, but he's had updates to that. The latest paper he had was in 2020, so it's pretty up to date. Now, you know, they made the estimate of the termination date of cycle 24 in April 2020. As far as I'm aware, I've not seen that confirmed yet by him. So as that termination date of cycle 24 extends outward, that means the time in years between the termination date of cycle 23 and 24 is longer, which means the solar cycle will likely be smaller. So we just got to wait and see if that termination date is occurring now, or if it lasts another half year, another year. That may drive their prediction down more to a smaller cycle. But we can be hopeful. That's all I can, all I can say right now. And I'm going to make my prediction for cycle 25 in 2025. Yep. Yep.
Anybody's got any questions for Carl? Go ahead. Carl, you made a comment which certainly got my thing about 6 meters.
Yep.
And I have a stepper antenna which got like 6 elements on 6, but I was thinking of taking and putting a pair of stacked loops on top of the end of the tower, so I don't have, because I'm kind of worried that, you know, I got the thing pointed, and when 6 opens, who knows? Have you done anything like that?
Yep. Well, yeah, I have a little MFJ 3-element 6-meter antenna. Now, I also have a Tenadyne T6 log P. It's only 6 elements on a 12-foot boom, and it's from 14 to 30 megahertz. But I've worked a lot of people on it on 6 meters. So at least I can turn the antennas, have antennas pointing in 2 directions. And I've looked at the T6 on 6 meters in 4NEC2 antenna modeling, and it does have directivity. And surprisingly, the Visuar isn't too bad, and it works. So I'm lucky. I've also thought about taking 4 3-element 6-meter Yagis and mounting them every 90 degrees around the tower. And if you model that, you can see that there's not much interaction between them, because either the other 3 antennas are off the side or off the back of the one you're using. And you could get like an Ameritron 4-position remote switch, and, instantaneously, look in 4 cardinal directions, which should pretty much cover openings, I believe.
Yeah, that was what I think I read an article where some guy had put 2 loops,
Yep.
stacked them and got, some gain out of the thing.
Mm-hmm.
That's pretty good, because then they're not pointed anywhere, but you're still getting a fairly low angle on most of the stuff.
Yeah, and another way to do it is, you've probably heard of a turnstile antenna, which is, 2 half-wave dipoles fed 90 degrees out of phase, and it gives you circular circular pattern in the horizontal plane if the loops are horizontal, or if the dipoles are horizontal. So that's another way to do it. You can stack 2 of those too.
Yeah, I don't know if anybody in Red X is doing anything like that for 6 meters.
I don't know how I think 6 meters sporadic E during this summer was pretty good, at least here in the Midwest and the East Coast. How was it out there?
Well, for me, it wasn't as good as last year. Somebody else.
Okay.
I've not spent a lot of time on 6 meters, but I did work into Europe from here this past summer. So it was
great.
Yeah, it was. I think 2 years ago was better on 6 meters for me here in California. Okay. I worked 2 Europeans and the usual tons of Japanese stations, but it hasn't been that good this year. And 160 really stunk out here. I was just looking back at my log, and I have something like 185 DXCC entities confirmed on 160, and the whole bulk of them was about 9 years ago. It seems like there was some really good conditions. So I'd come in every night, I'd turn on the radio, and there would be Europeans all over the band, and now it's like rare.
Yeah.
What was
I see lots of spots on. Go ahead.
Yeah, what was happening back 9 or 10 years ago that 160 was so good, or at least for me in California?
Well, I kind of think that I mentioned galactic cosmic rays.
Yeah.
What they are very energetic protons coming in from our galaxy from all directions, day and night. And because their energy is so high, they can get down at D region altitudes and cause collisional ionization. So there's more electrons created down at the D region. More electrons in the D region is bad for absorption.
Right.
It increases it. So I think what's could be happening is because the sun, we are in such a deep solar minimum period that there's more absorption and it makes signals weaker, and they were kind of weak to start with, so it doesn't help that they get weaker.
Mhm.
Now, what that also kind of suggests is as the sun's magnetic field starts getting stronger, it's going to keep out the galactic cosmic rays, and hopefully we'll see some better 160 meter propagation in the next maybe year or so before we get lots of solar flares and all that kind of stuff. But
Let's hope.
we'll have to wait and see. Yeah, all we do is hope. Do you guys get you get a good JA opening to on 6 meters usually?
Yes.
Yes.
Yep, definitely.
Yeah.
Yeah.
There seems to
Yeah,
be
I know there's
a pipeline between here and Japan.
yeah.
In all bands.
Now, whether it's some kind of multi-hop sporadic E or are any of you aware of Jim Kennedy's K6MIO's presentations on 6 meter long path 6 meter propagation or long distance, I guess? He's got some pretty interesting, this is something, maybe this is what's happening, chordal hop or, the 6 meter RF goes up and refracts off the top of the cloud. So it doesn't hit ground at all any time. There's also, let's see, what was this, JA, I can't remember his call right now, but he called it SSSP, some short path, whatever it is. But he postulated that it was due to polar mesospheric summer echoes, and looking at data says that those things, up at high latitudes can have enough ionization to refract 6 meters if it's at very low angles. So I'm not sure we'll ever figure out how all that's happening. All we can do is kind of guess based on our understanding of the physics up there.
Right.
Yeah, since I've only been in California for like 4 years, has it been everybody's experience that all the propagation on the higher bands to South America is better than I certainly remembered on the East Coast?
Better?
Yeah, I mean, I maybe because it was so easy to work Europe from the East Coast, that maybe we just ignored South America.
Yeah, that could happen.
There were a fair number in the ARRL 10 recently.
Yep. And again, that was the CQ Worldwide phone was really good, and that was because there was a very nice spike in solar activity that really helped, and it still was kind of good for CQ Worldwide CW. 10 meters, yeah, it certainly was better than most people thought it would be in the 10 meter contest.
Mm-hmm.
Oh, that was great. Thank you so much.
You're welcome.
Yes.
Yay.
Yes. Thank you, Carl.
Okay.
Thanks, Carl.
Let me stop.
Thank
I'm going
you,
to
Carl.
stop sharing the screen.
I did a quick lookup. That is the short path summer solstice propagation.
Solstice. That's right.
Yeah.
Yeah, and it was the J1 something or other.
There's a G3 WOS, and
I think
and
he
so on.
translated it. He translated it from Japanese into English.
Ah, okay, yeah.
I believe, because it showed up in the UK's 6 meter newsletter, whatever that's called.
Okay.
Yeah. Yeah. Interesting.
Well, thank you. I'll see you.
Thank you.
Again, Carl.
Okay. Yeah. See you next year, and maybe things will be really rip roaring on the higher bands. Huh?
You bet.
Would be nice, wouldn't it?
Absolutely.
How many? I got my novice license in October '61, so I missed Cycle 19's peak. It'd be nice to experience a big one.
Mhm.
Of course, cycles to 21 and 22 weren't bad at all.
No.
I mean, they were, they were good also. Not as big as Cycle 19, but they were getting close. And boy, they sure made a difference on 10 meters
Mhm.
and 6 meters. Although probably back then, not a lot of people were on 6 meters like nowadays with all the rigs covering 6.
Before I'm going to honor my